Hello, everybody. Welcome back to Build Live. My name is Tim Hewer. We're here now talking about Azure Data with my friend Rohan Kumar. Rohan is the corporate vice president of Azure Data Services, all data, right? Is that correct?
That's right.
All right. And so, Rohan, you just got done doing one of your sessions here at Build. First of all, how was it?
Oh, it was super exciting. I mean, lots of energy. I think it's always great to come to the community at Build and be with the developers, be with the data engineers, analytics, and there's just a ton of excitement in the air.
Yeah, it's good. I'm trying to remember of any application that I ever use that doesn't involve data, and it pretty much doesn't exist, right? So
That's about right.
yeah. So the backbone of any good solution that we as software developers are doing, there's data somewhere in some form, I think, right? So,
That's correct.
And
Yes.
you're here to help us through that. So walk us through, for those that might not have gone to your session or are going to watch it later online, what are kind of 3 takeaways we should take away from that and we can kind of learn from as we're rewatching it again?
Just 3.
Just 3. Pick 3. Yeah.
I mean, it's sort of interesting, right? Like one of the things, as we've worked very closely with developers who are sort of building out, new applications in the cloud. I mean, so many new scenarios. There's some consistent themes that come across, and I'll sort of maybe speak a little bit about that, and then get on to what the announcements that we did. The first one's really around just the volume of data, the variety of data, the pace at which the data is growing is just phenomenal. It's almost sort of getting really, really hard to, manage it within the, scope of the application. And usually, what happens is once, the data volumes grow beyond a certain scale, it lands up impacting the application and the workloads in a negative way. Then the developers land up spending a significant amount of time, usually with very expensive solutions, to actually work around those scale problems. And the final thing just is around security. While you're sort of dealing with all these challenges, how do you ensure that as you're dealing with data, especially more of the important or confidential data, to make sure that it's very highly secure, it's compliant. So these are some examples of challenges, and sort of I get back to some of the work we've been doing in many cases over multiple years that we sort of announced today. The first theme is just around being able to deal with data at very, very high scale for your relational workload applications, right?
What is high scale these days in your terms?
So again, it varies significantly based on the kind of workload you're running. So for example, when you look at a relational database, you have SQL Server, Oracle, these are the traditional databases. For them, getting into hundreds of terabytes lands up being super high, very, very high scale. When you think about big data, when you think about more scaled out systems like NoSQL, what we have with Cosmos DB or Azure Data Lake, those get into more of the petabyte scale.
Wow.
Right. So even today, when you take a look at relational database workloads, when they start pushing the boundaries of 100 plus terabytes, they start running into significant challenges. Just for context, to build out an application that supports this volume of data with the expectations around latency and throughput, which are just only increasing, you have developers who work with their admins. They build customized hardware. Like in a lot of cases, very, very expensive machines, expensive hardware when it comes to networking and things like that to build a solution together that matches the SLAs. What we aspired to when we started working on some of these challenges a couple of years ago is to basically solve the same problem over commodity hardware that we have in the cloud. So you can imagine, you sort of run into physics in many cases of how to solve for this. But anyway, so if you take a look at the large-scale relational database workloads, the announcement that we made today was this technology called hyperscale that we're shipping, as a part of Azure SQL database and Azure Postgres database service. For both of these, what the technology enables is to start pushing the boundaries, of the data volumes, throughput, latency you can handle. So with this technology, typically the challenges you run into, with a relational workload, where you're running short of compute resources or memory or storage. Hyperscale essentially allows you to transcend all of that, and it understands, the needs of your workload and scales out storage automatically for Azure SQL database as an example. But you don't need to think about, well, how will my application deal with 100 plus terabytes? And the way we sort of designed this at the guts of it is we had to replace or completely rewrite the storage layer of the relational database. Innovations in this space, the last happened around late 90s, right? So and then we basically had to build this cloud native solution that in theory doesn't have any limit on the size of the relational database you can support. But we've certified it up to 100 plus terabytes.
That's
We're
amazing.
working with a lot of customers. On the Postgres side, we recently announced an acquisition earlier in Jan of this
Yeah, with
company called
Citus.
exactly. And they've been phenomenal, actually. I mean, in some sense, just the value system culture and the technology that they were building aligned very much with how we're looking at being for Azure being the best place in the world to run your Postgres applications, right? And they also sort of are pushing the boundaries. And what Citus has done is they've basically leveraged the extensibility model that Postgres provides to build out a single system image which underneath the covers uses scaled out compute to back a database. So you can imagine, you specify this notion of a partition key, then as your data volumes are growing, Citus, the core technology, intelligently shards your database without your application ever having to be aware of what's happening underneath the covers.
Yeah, that was the question I was going to ask you. As you talk about like hyperscale and the growth of data. Let's say I'm in my garage right now and I'm building the next great startup, and I've just got my Postgres database and maybe a couple megs or something like that, and suddenly something spikes, and now I've got that petabyte situation. As you were describing the kind of scale out, is this something that I, as the software developer, have to worry about? Do I have to go turn some knobs now and say, oh, more storage, as I know, or how does that exactly work? How do I plan for that as well?
Right, and that's a great question. In fact, that's exactly the problem we are trying to solve, where you as a person or a developer who's sort of building your application on the Postgres, you shouldn't have to worry about infrastructure. You worry about the business logic of the application. What is it from a value standpoint that you want to get out of it? Underneath the covers, the database service, the Postgres database service, should be able to scale to your needs. So if you see that, if the service realizes that, well, look, the rate of growth is a certain amount, then based on your application and your workload requirements, it should just scale out for you. Right, so you don't have to think about, how many nodes do I need as I manage my, if I'm going from, let's say, multiple gigabytes to multiple terabytes to tens of terabytes to hundreds of terabytes. You shouldn't have to worry about all of that, right? And that's the beauty of, what you get with hyperscale, where our goal essentially is, more and more developers start focusing on just the business logic, and they don't really worry about the infrastructure. And the managed services that we have for data and analytics take care of that for you.
So you mentioned a keyword there, which is helpful too. So analytics is a big part of data.
That's right.
What do we have that excites you about that? And how should software developers, how do they incorporate analytics as a part of their life cycle? How can I leverage the power of that? How do I benefit from, what I think of as, something simple, or maybe, a task that I as a developer have to do,
Yeah, so I mean, analytics is such a huge space. I mean, it's one of these things where I actually feel it's one of those very overloaded words where if you double click on it, it's like a billion different workloads you can run on analytics, right? And a couple of things, one of the things that, what I'm really excited about is the work we've done of deeply integrating Spark with Cosmos DB. Cosmos DB is, most of the developers are probably aware now, is a flagship, multi-model database service that we have. Guaranteed SLAs, financially backed for not just availability, but, throughput and latency. It's based probably in, my humble opinion, the best place in the world to run your Cassandra and Mongo workloads. And one of the things we heard from our customers is they're landing very, very large volumes of data inside Cosmos DB. So for them, that's their big data lake, right? And they needed ways in which they could run compute engines like Spark close to their data. It's already scaled out, it's already sharded. And how do you get the compute capabilities of Spark very, very close to the data that lives in Cosmos DB? So that's the announcement of natively supporting the Spark APIs, and we're seeing significant amount of traction, from our developer community and excitement around that. The other part was not just the fact that you can use Spark, but with all the APIs now, we have the support for Jupyter Notebooks with Cosmos DB.
Right.
So it's sort of becoming this very turnkey way of, trying out stuff, experimenting, especially in your dev and test environments.
And for those who don't know, what's a Jupyter Notebook?
So it's a experience that you have as a developer, where it's an environment that gets created where you can, just write down your queries, write down your code, and you get instant feedback as to what the results of the changes that you made, as an example. So it's just a very
heavily used in machine learning,
heavily
data
used
science.
in machine learning, analytics, data science, and these workloads. So that's the capability that we've added with Cosmos DB. Now, so that's the operational analytics piece. The other stuff that we've been working on is this whole notion of the modern data warehouse pattern, which is when you start looking at the disruption that's happening in the core enterprise data warehouse, where you had a Teradata or a Netezza or an Oracle or a SQL Server, whatever. And as customers are looking into migrating that to do more predictive analytics, AI, machine learning, the first step towards that is really building out what's called this modern data warehouse pipeline, which we see a lot of our customers do. And there are multiple key innovations there. One of the things that we announced in my keynote at Build was this two new features that we are adding to Azure Data Factory. Azure Data Factory is a flagship service that allows you to do, create ETL and ELT sort of pipelines in a serverless manner. It supports hybrid environments. And one of the things we hear from our data engineering community that builds out these pipelines eventually to do AI and machine learning is that they don't really like to deal with writing scripts, writing code. They want more of a visual declarative experience.
Okay.
Right? So just imagine you're able to walk up to a tool, a UI experience in Azure Data Factory where you're not really writing any code. You're just saying, I want to take data from here, join it with this different data set over this column, project this. And underneath the covers, the service here, in this case, Azure Data Factory, is converting your intention into Spark code.
Is this powered by, we're hearing a lot about AI, right?
Right.
Is this powered by AI?
That's right.
Infer that?
Yeah. So I mean, at some level, this is statistics, right? Statistical analysis that you do. But you're right. I think there's a lot of intelligence that goes into understanding what's the intent of the data engineer.
Right.
As they're working with almost zero code. They're working with
They're just working with entities that they know, right?
They're working with They're working with entities that they know it's a visual experience where you have data sets in front of you where you can sort of munch them together, set up these pipelines. And it's actually, I'd say, a phenomenal shift in terms of what's available in the public cloud today. I mean, if you take a look at none of the clouds support this no-code experience. It's one of these services that has seen amazing amount of adoption. I don't think there's been any other service in a preview state where we've seen such high adoption. And eventually that connects very well with SQL Data Warehouse.
Right.
That's where the data lands. And we've been sort of talking about all the investments we've made around performance, security, workload management, etc. Because as you look at data warehouses getting into petabyte scale, all the work that was done in the past to get them to work just doesn't hold true at the volumes of data we're talking about. So the last couple of years, we've done significant amount of investments in just increasing the scalability and price performance, right? Which is how much do I spend to get the performance out? That's a very important metric when it comes to picking a data warehouse. And hands down, I mean, we have independent studies done by GigaOM, which is a pretty popular tech blog,
Right.
where they measured us, they measured Google, they measured Amazon. And Azure, with our data warehouse product, just beat them hands down. And they'll be hearing this from our customers as well, right? Of how we are putting these together with Data Factory. The other big announcement we made was around just release of this feature called data wrangling. So imagine, once you land the data, now you have all this data in front of you with this experience with looking at entities, and you're just not happy with the way it's shaped. Now imagine you change the data in one particular cell, and rest of the data just changes based on the intent you had. And that's where we use a lot of machine learning and AI
Got it.
to look at the structure of how users are changing data. And again, it's completely no-code experience.
And is the official product data wrangling?
It's
I
called
think you
data
should go with
flow
that.
wrangling or something like that.
Yeah,
I
stick
forget.
with wrangling. That's
Yeah.
awesome. Make it
Yeah.
a lasso icon or something
Right,
like
right.
that.
So that's those with Cosmos DB and Spark and then Jupyter Experience. What we're doing with Azure Data Factory with data flows and data wrangling, and of course all the work that's gone into making SQL DW just like a phenomenal data warehouse, and built for the cloud as this thing is there. And again, sort of to round up the news, and then we can sort of get into the details. There's two more things. One is this whole notion of edge computing. That's of course become super popular.
Right.
And this is one of the things we have. We work with several analysts, and over the next maybe 2 to 3 years, you'll see this where 70% of the data that's actually getting produced is going to be on the edge devices. We're talking about hundreds of billions of these intelligent ones. They have a certain amount of processing power. They're able to run machine learning algorithms to do things like scoring, and they have locality of data, so there's a ton of context. So the big announcement we made there was this notion of supporting Azure SQL Database Edge. So it's the same SQL engine that all the developers know and love. They've built solutions on premises. They've built solutions in Azure. And the entire surface area now comes on these edge devices. So you could be running on ARM devices, Linux, Kubernetes containers, Windows, of course.
Solves a lot of problems, and especially a lot of maybe less industrial countries, or the farms that we
That's
always
right.
talk about. Bringing the power of all this computing to the edge.
Computing to the edge. And now,
Yeah.
and the other part is of course, Satya's spoken very broadly, Scott, Jason, around the whole intelligent cloud and the intelligent edge.
Right.
And people sometimes think it's just a matter of all these devices and they get connected to the cloud. It's a lot more than that.
Yeah,
right?
exactly.
When you think about consistent application model, right, which is I'm writing my application and my workloads. Portions of them run on premises, portions of them run on edge devices. A bunch of that stuff runs on Azure. So you need a consistent app model. You need consistent security principles. Identity needs to work seamlessly across the board. And finally, the manageability pieces. How are you going to manage these billions of devices which are connecting to the cloud? So you have to almost rethink. And I think that's one of the things, if you take a look at what we've done with all the support for Azure IoT, the work we've done with Stream Analytics, and now with Azure SQL Database Edge. I do, with all humility, believe Azure is the place when you think about cloud and edge computing, the consistency along the dimensions
Across
that
the whole stack and the whole
there is
problems.
no other cloud that even comes
Right.
close to what we
Great,
have.
that's awesome. The few minutes left that we have, I want to throw some questions at you. So I think you mentioned a lot of things like Spark and Cosmos and SQL. Like as a developer, like where should I look of how do I choose which data is the right solution for me?
And this is a common question that we, just given the plethora of services and choices that we have, a lot of it lands up depending on the workload. And it's never usually a specific database. If you take a look at, I'd say almost 90+% of all the applications that I see deployed on Azure use multiple of our database services. They'll use SQL DB, they'll use Cosmos DB, they'll use open source databases like Postgres, and to build out the solution. And typically, if you take a look at it, there's a couple of ways in which they decide that. One thing is their own familiarity with a specific database.
It's a common theme we hear, right? Like, where are your skills at? Where are your
skills
maybe
at,
where your system's currently at, right?
That's right.
Exactly.
So there's a lot of experience that you have to respect. Where in the past I used to joke about this, where we used to speak to developers and say, "Let me tell you what you're doing is wrong, and this is really how you should do it."
Yeah.
And they're like, "Well, nah, I've already decided, and it sort of works for me, right?"
Yeah.
And the approach right now in Azure is very different, right? We basically are like, look, we realize that there is no one choice to fit everything, not just in terms of workloads, but even in terms of skill set and what their preference are. You have open source developers, who would prefer, Postgres, MySQL, Cassandra, Mongo. You have your .NET developers, and we have millions of them, who would prefer, SQL Server and all the ecosystem that's built around it. So the way we approach this is, look, we want, in all humility, we want Azure to be the best place to run any of your database workloads, whether you happen to come. And then there's purpose-built solutions, right, where there's a lot of, again, like I said, volume of data, the kind of queries that you're writing, the SLAs that you expect in terms of the response times. Based on a lot of those things, there's a lot of detail that we provide in terms of patterns that we see emerging
Some
from
guidance
developers.
around them.
Absolutely.
Yeah.
So if you go to the our Azure.com website, especially on the data services, there's lots of patterns that are called out based on what we've seen developers succeed with. Yes, it's not super
Not
turnkey.
a one solution answer. And
No.
I think we're seeing this trend a lot, right? It's very heterogeneous, right? Multi-cloud, kind of multi-solutions, multi-technology. This is the real world that developers live in.
You're absolutely right.
So there's no like, oh, you're going to only use SQL here. You're going to only use Mongo.
No, it doesn't work like that. And usually, and I think as this whole cloud, new applications that are being for the cloud, especially around with the edge, etc., becoming more commonplace, you see developers are getting a lot more mature and experienced about the same thing.
Yeah.
So anybody who stands up and says, well, I have this one thing that solves all your problems, you very soon, I think you're going to lose complete trust with the developer.
That's right, yeah. All right, we got 30 more seconds. I'm going to ask you a question, see if you can reveal some data for us. What's the largest database in Azure right now?
Oh my God, largest database, it's probably multiple petabytes. Well, I mean,
wow.
Especially on more of the, when you think
we
about the
keep
analytics
scaling up every day, I'm sure.
Yeah.
Right? Well, this is awesome. A lot of good data announcements. So go back and watch Rohan's presentation, which was today, Monday, right? So you can go back and look at Monday and learn more about these in detail. Follow on some of the trends that we see with data, and go try out some of these Azure solutions today, right?
Yes, absolutely. And I'm super excited to see what our developer community does with it.
Thank you so much, Rohan, for joining us here for Build Live. and really appreciate you sharing some of the announcements that we shared around data and getting excited about building apps.
Well, thank you so much.
Thanks.